Hi, welcome. It's Gene from maverickstar. The reason why we're looking at the chart is because I was just watching a YouTube video where CERN in 2022 were conducting the third run of the LHC experiments, but it was after that they discovered that it had actually, but you know what, I don't like normally to talk about this, but it actually affected, according to some of their sources, the geomagnetic field of the Earth. As a result of that particular one experiment, they have had to relook at how they conduct the experiments in a more safer way, that it doesn't directly affect the geomagnetic field of the Earth. Now, I know some of you guys have been saying for a long time, LHC are responsible for perhaps the cause of the the pole migrating in the star, and that's not the case. I'll explain why. Because LHC, when the pole started to migrate in the 1200s, wasn't even built then, so we know it's not the LHC that has caused it to start migrating. But what we got here, when I went back into the archive of July from the 19th 2022, I did spot an anomaly in our readings, and it wasn't picked up on just one of our detectors, it was picked up on actually two, and you can see it there. The blue line represents the two detectors, the brown line represents the point at where the heading changed and increased to between the point 1 and point 2. That would have been 6 seconds. That's how a higher resolution we can go back. So we can go back to any day that we've been collecting the data, to any hour of that day, and then pretty much any second of that day. So what we find, looking at our data, if it was after the 19th that they was conducting their experiments, is what looks to me like the magnetic North Pole had shifted within a few seconds over 150 miles and then went back. And I'll show you what that looks like with the bulk data. So what we've done is we've just filtered two readings out of the detectors that we've got from that point in time, where we can see that there does look and appear to be an anomaly. And we went back and had a look at it, and it certainly looks like there is an anomaly there. I can't prove whether that is the exact date that they conducted that experiment, where they found that they'd obviously affected the Earth's geomagnetic field. Because all I can find is that this experiment was conducted, that the third run in 2020, from around from around July. So we've got the whole month's worth of data. So if any of you guys can find out the hour and the minute, we can look into the resolution of what we've got here, and we can have a little more of an investigation into that, and just how much did CERN affect it. The other thing I want to say is, just because CERN's Hadron Collider is a 25-mile circumference, so it's a huge magnetic ring, and there's supermagnets, the magnets and that ring itself isn't enough to affect anything to do with our Earth's magnetic field. I'll just put that out there. I'm just telling you now, it's not. You could stand with a compass while that is running at full pulse. 13 trillion electron volts, is it the experiment that they was running back in 2022? It isn't enough to affect a compass 10 miles away. But the nature of their experiments, the collisions of the particles, are. And I think that that's what exactly happened. It wasn't the strength of the magnetic ring, it was the actual outcome of the experiment, the collision. And it was the collision that caused the problem. And they even said that after the experiment it was prolonged for a short period of time. Well, we can see maybe 6 seconds. So whatever effect it had, it shifted the north magnetic pole probably 150 miles, and then it went back. But they must have then, after finding out what had happened, realised that the nature of their experiments are quite dangerous, in the fact that they can, do that to the magnetic north poles. Can you imagine if it had run out of control? it could have led to a geomagnetic reversal of this Earth and a collapse of the magnetosphere. And that's probably, if you do a little bit of research, on the third run, the scientists were shocked. They said the outcomes was completely evil. Maybe it's because they realised they were completely out the depth. And as a result of that, new safety precautions have had to be implicated now into CERN's actual running of the LHC. So, you know what? But then, you know, I'm not surprised with scientists pushing the boundaries of these experiments in the way they are, because, you know, if you look at the Manhattan Project, when they were trying to build the first nuclear bomb, they weren't sure whether they're going to ignite the entire atmosphere of the Earth. But nevertheless, they still went ahead and did that. So let's have a look at the bulk data in the chart. And this is nice because I don't usually show you the raw data that we collect from the TriMag system. So let's have a look at the bulk data and that particular point where this anomaly shows up. So this is a larger part of the data. You can see we've got 97,015 individual 3-second data sets, and I've put the filter on in Excel so I can filter out all the others that, you know, are like uncertainties. And if you follow us on the website, you know that sometimes we collect 400,000. That's because there's a lot of seconds in a month, and every 3 seconds we collect data from 3 detectors, so that's why it mounts up to such a lot at the end of the month. And that's why, you know, obviously we keep the data as well, so we can go back to 2022 from the 19th of the 7th, and we can have a look to see if there's an anomaly. And surprisingly, you can see where the green line shoots up the top there, and the red line is massively increased from its normal. You can see that there's obviously an anomaly there, but whether that coincides with, you know, the hour and the minute at the point in time where CERN was conducting that experiment is not completely known, because I don't know what that time was, and I could find out on my data because we date time group it, but whether it lines up with what CERN's date, hour and minute of that outcome of that experiment where, you know, it affected the Earth's magnetic field, you know, we will never know unless somebody tells us. But on this time, on this day, on that hour and around these minutes, that's when we conducted the experiment and we found the anomaly. So, you know, we can cross-reference and check our data with others, but we need to have the accuracy of the time it occurred for us to be certain that we picked it up here at the Maverickstar Observatory. But I thought, you know what, it'd be worth sharing that with you, you know, because it's quite shocking, isn't it, to know that over in Geneva, is it, where the Hadron Collider is, there are scientists conducting experiments that, not through the nature of the strength of the magnet, the nature of the outcome of the collisions that they're causing, you know, can have you know, a noticeable effect on our geomagnetosphere and the dipoles on our planet, and maybe even the magneto-core. It's all electromagnetic, and let's face it, what CERN are trying to do are look into the actual Big Bang of our universe. So it gives you an idea of, you know, the level of what's the best word to use? The level of the nature of the experiment and the possible outcomes. I mean, they don't know if one day they crank up the, you know, the Terra electron volts up to a specific number, that it creates antimatter, and that antimatter just annihilates everything within our solar system, not just on this planet, anything it comes into contact with. You know, we have to be very careful. I think experiments of this nature should be conducted off the planet, not on it, in the future, just to safeguard, you know, any event like, you know, creating or, you know, setting up the parameters for a geomagnetic reversal to take place accidentally. Anyhow, guys, I thought I'd share that with you. If you want to support us, there's a link down there. We hope you do. You know, we are an observatory. We collect data unlike a lot of people that talk about this subject, and I've just demonstrated that at any point in time over the period of time that we've been collecting the data, we can always go back and analyse it. And the reason for that is because I know that this data is very important and valuable, because if we experience a magnetic pole reversal in the next month or two, we've got the data that led up to it at a resolution of every 3 seconds before the event, and that's all the data you'd probably want to analyse what actually took place and investigate it. Okay, link down there. As always, guys, have an amazing day. Take care of your loved ones. Bye for now.